Hello again. Welcome back to Charlie's Unimog Workshop. I got something a little different today. I've been working on the inside of this camper for a few months now, and during that time I knew that I was going to need to have some tank level indicators for the fresh and gray water tank. I'm not going to have a black water tank, but as an engineer, any engineer out there knows that without a manager keeping you on track, we tend to see something we call scope creep. And I'm definitely at risk. And today I'm going to show you where I've gotten to on this tank level sensor project. As I started doing it, I started adding features, and it's sort of an evening project that I do when I'm inside after working out here and sit down with a laptop and start crunching code. Anyway, I'm going to go over, I've got a little workbench set up where I can show you the state of the project now. I'll have another video probably in a couple of weeks where I'll have this thing packaged up and installed, and I'll show you how it works. But at this stage, it's a little bit, I mean, it's messy, but you can see what's happening better than you'll be able to see when it's in the camper installed. So hang tight. We're gonna move over and I'll show you what I got going. Okay, here we are over in the wood shop with my little bench set up. I thought I was going to do some anodizing today, but I am short distilled water, so that'll be another day. You might recognize this this format. I've sort of ripped a page out of this old Tony's playbook, but that format fits well here. So what we have here, I started with an Arduino and one of these little LCD screens, and my thought was I was going to, it's smaller than a 2-inch diameter by a little bit. It's about 1 3/8 ish, and so I thought I was going to build this into a 2-inch bezel so it would fit into a standard gauge hole, and then that's going to go into the control panel on the electrical cabinet side in the camper. And so I started with an Arduino and immediately figured out it doesn't have enough memory and it's slow. So I started scouting out what's a better microprocessor to use, and I've used the esp32 in this project, and that is so far working out well. And I've just got it on a little experiment board here so that I can pin it up. And as I started this project, I hadn't used the esp32 before, so I wanted to play with some things and figure out how to get the screen to play nice with it. And so I didn't start with the actual level sensing. I started with just making the display work. Well, that turned into, here I got a little battery pack I'm going to plug this into. So I now have a little splash screen. You Unimog folks out there will appreciate that. A clock. So we've got a real-time clock module right there. No, right there. That is supplying the time. I've got indoor and outdoor temperature. Right now they're both indoors. They're on the same board. And then I have level sensing, and that's over here. So it cycles between those 4 images, unless I want to monitor one more closely. So this just cycles through all the information, and then I have a couple of, it will eventually have the display and 3 buttons. Part of that is so that you can set the clock. That's actually the only purpose for the second 2 buttons. The first button selects the mode. So right now we're in this cycles through all the screens mode, but if I push the button, it should go into clock mode, and it'll stay there until, if it has in fact successfully done that. It seems to have. And then I hit the button again, and it goes into indoor and outdoor temperature mode. That sensor's a little bit slow, but it also gives me relative humidity. And I wanted that because, you know, if it's highly humid inside the camper and it's cold, much colder outside, you'll get condensation in the walls. So you might want to think about ventilation and get some of the moisture out before it wrings itself out on the walls. So we got temperature and humidity indoor and outdoor. Hit it again, and then we have the tank levels. And it's a little glitchy. I just finished this one last night. So, but as I move the slide up and down, I have these both connected to the same indicator. But one is going up, one is going down. I don't know why it's not focusing well. Anyway, I did learn a few things. For one thing, I thought that this float was had a continuous readout, but it does not. It actually has, I think, 9 different sections. And I think what's going on here is, I'm pretty sure there's a magnet in here, I haven't checked, and probably a Hall sensor mounted in different locations on a long skinny board in here. And as the magnet traverses up, it hits or indicates to the Hall sensor underneath that the magnet has passed. Not positive that's what's happening, but I'm pretty sure. Anyway, so what we got here on the board is we have a real-time clock right here. So that's got a battery in it so that it'll maintain the time as the power is cycled on and off of the board. We've got 2 temperature and humidity sensors. And then I've got this level sensor. And once I have the other tank and I know how deep it is, I'll get the other level sensor and that'll be ready to go. But I'm probably not even going to hook that up until it's in place. And I still need to make a little bit more of a proper board. I don't think I'm going to go the route of a printed PCB because I really only need one. So I think I'm going to use one of these cookie cutter boards. We'll see how that works out. But then there was the problem of how do we make this into put this into a bezel, because that's a goofy shape. I don't know if you can see the shape of that board, but it's got wires coming out this side and it's got this funny tab on this side. It's not round. So that's my solution to that. So this is what I thought I was going to anodize today, but without distilled water, that's out. But let me take this apart so you can see how that works. So there are 2 pieces to this housing that are held together. Some little M4 0.7 screws that I'd like to not lose because I think I have a grand total of 4 of them without going back to the hardware store for something else. All right. So that board wiggles in there. So this is just a turned aluminum part. Had a couple of little pieces of scrap aluminum that I was able to chuck up and turn. And then I milled out a couple of grooves here, drilled the holes and tapped them. And with a little bit of fiddling, that board drops nicely right in there. And looks like that on the front. And then this side, actually, this is the prototype. So there's a couple of features when I do this. If I were to do more of these, this would just be a flat plate and this would be a little bit shorter. But I wanted to sort of make sure I had lots of room to make edits if I needed to. So this piece was just a turn piece, 6 holes drilled in it. That center hole is because it was a scrap piece of aluminum that happened to have a center hole. And then I milled the slot to coincide with the location of these wires coming out. And together it goes. Actually, I have some longer cables coming because I anticipate when I install this, it's going to, the box will be a little bit farther away than this. And I want to make sure, and actually I've got a plug on each end of that wire so that I can solder a header onto the board and just plug the other end in. Anyway, so interestingly, I was not able to find anything like that online. There are some other ones that are where the whole thing plugs in, and there's another version of this board that has the esp32 microprocessor on the back of the display itself, which I didn't want to do because then I'm trying to fiddle around with plugs in here and stuff. And then you're forced to use USB, where I'm going to be powering this from the battery. I've got this uses a 3.3 volt power supply, as opposed to the Arduino with a 5 volt. But it's easy enough to make a 3.3 volt power supply off of the 12 volt battery system, and that'll be the power source. So, and then of course that is a 2-inch diameter that fits into a standard 2-inch hole. So when it's all in, it looks, something like that in a panel. So I think my panel is going to be aluminum. I've got a little block of aluminum that I'm going to use, and I put some switches in, and for the water pump and for the water heater, and probably one to power the whole board. Haven't quite figured out what that's going to look like yet, but that's easy stuff. Anyway, if you like this content, this is a little different than what I usually do. And if you'd like to see more about this project code, the coding is a little bit interesting. So if I drop a comment, and I can make another video about that. I expect to be doing a anodizing video here in the next day or two once I get some distilled water back in here. I think I have everything else. I'll double check that, and then that'll be a fun little project. I did a couple of parts last summer with mixed results. It took 3 tries, but I got really nice black anodized on at least one part, and I took notes as to how I did that so I can hopefully replicate it. And then I'll have another one in a couple of weeks again that has this all on a board and in an enclosure and installed. So hope you enjoyed it. Throw me a like, and if you have any questions about it, feel free to leave a comment, and we'll see you next time. Thanks for watching.